Welcome back to Geometry Classroom. Today we'll talk about similar solids. We have two main objectives. Students will be able to identify ratios between the values of similar solids, and students, as language objectives, will be able to find the missing values using proportions between similar solids. Now, I hope you remember similarity of geometric figures. We had this lesson when we talk about similarity of triangles, right? And then we learn that two triangles are similar when they have the same shape but different size. And this is also valid for solids, right? So, two solids are similar if they have the same shape but different size, right? Now, as we know, right, in order for two solids or more solids to be similar, the ratio of their corresponding dimensions must be in proportion or proportional, right? The ratio of corresponding linear dimensions of two similar solids is called similarity ratio, right? For example, any two cubes are similar, right? Or any two spheres are similar, yeah? We have a theorem that states if the similarity ratio of two similar solids is A to B, right? Let's say if the similarity ratio of two solids is A to B, then the ratio of their corresponding areas is A squared over B squared, or is the square of the ratio of similarity. And the ratio of their volumes would be the cube of similarity ratio, right? In other words, V1 over V2 would be A over B cubed, or cubed. Or if you like, you can say A cubed over B cubed. And here, A squared over B squared. Yes? Now, let's have a few examples to have a better understanding, right? In this case, are these rectangular prisms similar? If yes, what is the ratio of their surface areas and ratio of their volume? First, we have to identify the similarity ratio, right? To find the similarity ratio, if there is one, we have to find out, right? We have to make the ratio, right, of the corresponding dimension or the corresponding sides, right? We have for solids 3 dimensions, right? Their corresponding dimensions must be proportional. In other words, their ratio must be the same, right? Now, let's start with this prism, right? because this one comes first. Now, which means its dimensions are on top of the ratios, right? The corresponding dimensions of the second prism should be in the bottom, right? Now, let's start with 3. Is on top, right? The corresponding dimension for this side, right, in the other prism is 4.5. So 4.5 goes in the bottom. We continue with the other dimension, height, right, of this prism, which is 4, is on top. The corresponding dimension in the other prism is 6, comes in the bottom. And the last corresponding dimensions are 5, which is on top, and 7.5 in the bottom. Now, in order to see if all of these 3 fractions are the same, we have to simplify them. Now, to simplify them, we have to get rid of the decimal point. We get rid of decimal point by multiplying both numerator and denominator by 10, right? So you're going to have 30 over 45. Yes? Now, we have to find the largest common factor of these two numbers. And we can try 5 first, right? If we divide both 30 and 45 by 5, you get 6 over 9. But they still have a common factor, which is 3, right? So the resulting fraction in simplest form would be 2/3. Good. Now, let's simplify the second fraction. The largest common factor is 2, right? So you're going to have 2 on top after division by 2, and in the bottom 3. So that's the simplest form of this fraction. And the last one, again, we get rid of decimal point by multiplying by 10, and you get 50 over 75. As we can see, the largest common factor of 50 and 75 is 25, right? If we divide 50 by 25, you get 2. If we divide 75 by 25, you get 3. As we can see, all of these fractions have 2/3 as the simplest form of their simplest form, which means all of these fractions are the same, right? So we can conclude these two prisms are similar. Why? Because the corresponding dimensions are proportional, are in proportion. So the similarity ratio, let's say similarity ratio is 2/3. Now, question, what is the ratio of their surface area? We know the ratio of their surface area is, as we mentioned in the previous slide, is the square, right, of the ratio, similarity ratio. But the similarity ratio is 2/3, which means the ratio of their surface area would be 2/3 squared. Yes, so the ratio of their surface area would be, we square both numerator and denominator, and you get 2 squared over 3 squared, which is 4 over 9. That's the ratio of their surface area. Now let's find the ratio of their volumes. The ratio of their volumes would be the cube of similarity ratio, right? So would be 2/3 cube, which is the same as 2 cubed over 3 cubed. So at the end, we get V1 over V2, the ratio of their volumes. 2/3 is 8, and 3 cubed is 27. That's the ratio of their volumes. Now let's have another example. Here, what is the ratio of their radii if the ratio of the volumes of these cylinders is 125 over 27. In other words, here we need to find the similarity ratio, right? So, to find the similarity ratio, first, we have to write the ratio of the volumes, of their volumes, which is 125 over 27, right? That's the ratio of the volumes. We know the ratio of the volumes is the cube of the similarity ratio, right? Now, if you look at 125, 125 is the cube of 5, right? In other words, is 5 cubed. Why? Because 5 times 5 times 5 equals 125. 27 is the cube of 3. Yes? Why? Because 3 times 3 times 3 equals 27, right? Which is 5 over 3 to the power of cube. Which means the similarity ratio, right, is 5 over 3, which is the same as the ratio of their radii, right? So let's say R1 over R2. Yes? Another example. If the surface area of a cube is 20 square centimeters and the surface area of a cube is 5 square centimeters, what is the ratio of similarity between cube B and cube A? Again, the ratio of the surface area is, this one comes first, yeah, is 20 over 5. Yes? Which is the square, right, of the similarity ratio. Or if you like, a squared over b squared, right? Now, but 20 over 5 can be simplified, yes? The common factor would be 5, yes? So, if you divide 20 by 5, you get 4. If you divide 5 by 5, you get 1. So, the similarity, the ratio of the surface area would be 4 to 1, right? But 4 to 1 is in the same time we can express as a ratio of perfect squares. Would be 2 squared over 1 squared, right? Which is, if you like, 2 over 1 to the power of 2, right? So we can easily find and see the similarity ratio. The similarity ratio, right, of this, the surface, the similarity ratio between these two cubes would be 2 over 1. Yeah? That's all we have for today. Thank you for watching my video.